La nave Voyager 1 está finalmente enviando información de ingeniería y sobre su estado de salud a la Tierra después del susto que tenemos desde noviembre del año pasado. Y creo que es un buen momento para compartir esta charla que tuve con la Project Scientist de las misiones Voyager, Linda Spilker, que tiene una carrera fenomenal, más de 47 años trabajando en el JPL, en el Jet Propulsion Laboratory en Pasadena, California. Justamente Linda empezó trabajando con las Voyager hace muchos años y después fue nada más ni nada menos que la Project Scientist, la directora científica de la misión Cassini, para retornar hace unos años nuevamente a las misiones Voyager. Una odisea, estas misiones son espectaculares. Hace 47 años que están funcionando. Despegaron de la Tierra en 1977 y con Linda creo que barrimos poco de todo, de temas desde la historia de las Voyager, de cómo empezó ella su carrera en las Voyager, el equipo, cómo se fue reduciendo. Hoy en la parte de ingeniería hay 10, 12 personas trabajando, pero además hay otro grupo de científicos. Linda nos cuenta qué estaban trabajando a nivel científico justo antes que pasara el problema de Voyager 1, qué esperan recibir. ¿Cuál es la primera información que quieren recibir a nivel científico en cuanto ahora que se restablecieron las comunicaciones? Y la influencia, ¿no? La influencia en que han tenido estas dos naves que llevan ya 47 años viajando por el espacio, alejándose. Son las naves que más lejos ha enviado el hombre en su historia. Están en un lugar absolutamente desconocido y cada vez que nos mandan información es de algo de la cual no tenemos idea porque nunca el hombre ha estado allí. Y muchas veces esta información que recibimos va de la mano con los modelos que la ciencia predice y muchas veces, como nos dice Linda, es algo absolutamente nuevo que no teníamos ni idea. Así que, y la influencia que han ejercido en generaciones de científicos las misiones Voyager, así como Apolo, el proyecto Apolo ha influenciado a muchas generaciones de ingenieros aeroespaciales, astronautas, científicos. Creo que las Voyager las llevan, están muy cerca de ser un programa también increíblemente inspirador para muchísimas generaciones. Así que ojalá disfruten esta charla con Linda, ojalá que si tienen alguna pregunta la dejen en los comentarios, pero bueno, los dejo con Linda. All right, Linda, thank you so much. I know you're super busy. To be honest, I don't even know how to start this conversation. Voyagers have been such an inspiration
Oh, incredible.
of a mission for so many years, for so many generations of scientists. And maybe we can start with you. I mean, you've been with JPL for like more than 45 years, been a planetary
Actually,
scientist. Yeah.
I've been with JPL for 47 years. I started at JPL right out of college, first job out of college, the year that Voyager launched.
Wow.
So Voyager got its launch and I got launched my career at the same time. And so that was great. And then I worked on Voyager for 13 years, basically from launch through the Neptune flyby, a little bit past that. And then there was an opportunity to go over to another mission, which ultimately became Cassini. And so I then spent about the next 30 years or so working on Cassini, eventually becoming project scientist for the last decade and helping with the 13 years that Cassini spent in orbit. So that was a lot of fun. And kind of another part of my career path is that during the time I was working on Voyager, I was also going back to school and to work on my PhD. And I had been working with the science team, so I used Voyager data, watched as a star would go behind the rings, and as the star winks on and off, imagine taking a flashlight, shining it behind a picket fence. And so we could really get, very detailed resolution on Saturn's rings. And I was hooked. So I used the stellar occultations of Saturn and Uranus and Neptune to write my thesis. And then with Cassini, of course, I had a chance to go back and really study in detail Saturn's rings. So that was great. Then once Cassini ended, I never thought that the Cassini mission would end before the Voyager mission. So in 2017, we sent Cassini into Saturn, and I had a chance to go back to Voyager. And so I said, oh, this is a wonderful opportunity. And so, yes, I'll do that. I'll go back and and work with Voyager again. It just sort of like coming full circle for my career. So
And following
that's
the
really,
steps of Edward Stone, right?
yeah. I came in. I worked as Ed Stone's deputy, and then
Yeah.
when Ed Stone decided to retire, he had trained me, and we talked a lot about Voyager, where it's headed, the Voyager science, and put me in a very good position to fill very big shoes on Voyager. So I'm enjoying it tremendously.
I I cannot avoid to ask you about Voyager I. I was trying to read all
Sure.
kinds of information. I understand that since September, November last year, we're having this problem of trying to figure out what she's trying to tell us. And we kind of crack it out, kind of a message, and we are seeing readouts of its FDS memory, the flat dice system memory. Can you explain to us if this is a breakthrough, or do we have some hope?
Sure, I'd be happy to. Starting in mid-November, Voyager, rather than sending back all of its exciting science and data and engineering data, started sending back just a signal that didn't contain any information. It was like going from a conversation on the phone to suddenly just getting the dial tone. And so we knew that Voyager was still operating and pointing at the Earth, but now there was no information coming back on Voyager. And so then the process started with, okay, if you don't have any information, how do you try and figure out what's going on? And so we said, first, let's see if we can still command the spacecraft. Start just basic, turn things on and off, see if that works. That worked. And we got to the point where it looked like there's 3 sets of computers on Voyager: the flight data subsystem, the articulation attitude control subsystem, and the command and control subsystem. And so all those, the last 2, ACS, CCS, both appeared to be working. So we could say the problem must be with the flight data system. We kind of knew this was true because it was just sending back data that we couldn't, no information that we could use to decode. And so then we started sending up these, what we call memory pokes. It's hardware commands to try and different data rates and see if something might be working, because each data rate has a piece of unique software. And if the error that had occurred was in that unique software, maybe going to a different data mode would fix the problem. So we tried that, and it turns out one of the data modes was sending back information that was some detective work we figured out was actually sending back a memory readout of the flight data subsystem. And so with some very clever work by some of the engineers, we're able to figure out what was in that memory readout. And so they're still trying to carefully look through it, figure out what components or what places in memory might be bad, and find a way to work around it, maybe reprogram around it, maybe try writing in there in case there's just a bit flip in that memory location, and then to use that to get Voyager back. And so it looks very good, very, very hopeful. We haven't lost the whole memory. It looks like it might be places in the memory that we need to work on, but it's there, and it looks like it's accepting commands. So that's all good news.
Linda, after sending these pokes to Voyager 1 and receiving these readouts, this is something that expected, or these readouts were kind of a surprise? Like, why is she sending us all this?
The readouts were a big surprise. We didn't expect a memory readout from a data mode. So perhaps something else we'd done with these pokes, or something else unexplained or unexpected happened that allowed the memory readout to occur. So we don't know for sure, and we're just really grateful to have that information back and help us understand where the problems might be in the memory, and then to go ahead and fix those. So it was great.
No, obviously it's a great news. Voyager 2 is okay. Is still functioning and sending information, scientific information.
Yeah, Voyager 2 is still working well, sending back information. And so we do have one healthy spacecraft that's continuing to respond, and that's good. We don't want to have 2 spacecraft with anomalies at the same time and say, what at a time.
I think a couple of years ago I saw this movie documentary. It's Quieter in the Twilight.
Yes.
It's great. A phenomenal piece of cinematography. I don't know. I think I saw it twice or 3 times already. I don't know if the team is still working on that office, because I remember COVID was starting and they need to move to do home office. I don't know if you are back in that building, or you're working still working from home.
We're working in a hybrid mode, which means a few days a week, typically 3 days a week, go into JPL, and then a couple of days a week work from home. And it turns out that they're no longer in that building, and instead are back in a building a building at JPL called Building 264. What's really nice about that is when I worked on Voyager, when it was a mission flying by the planets, that's the building where I had my office. So
Wow.
now I have an office back in Building 264, the same building where all of the Voyager people were for the planetary flybys.
Um, yeah, watching this movie was this documentary, it was impossible not to get attached to the different member teams. I have this screenshot. Well, this is the documentary. Obviously, you know it. For the ones who haven't seen it, this is extremely recommended. And I guess most of these are still working on the team, because, for example, with the problem of with Voyager One right now, I can see, after watching this movie, I can see Enrique or Fernando still scratching their heads and working on their desks, trying to figure out what's going on. Is this something that's happening every day?
A couple of people have retired
Yeah.
since that movie was made, and we've been training up new people to take to, for their jobs, for their role. But most of the people that you showed there are still working on Voyager in the same roles that they had for that movie.
Wow. Um, and in that movie, they were mentioning, even what I think it was 2019, 2020, they knew they were facing the end of the mission. And it was almost like 4 years ago. And the objective was, okay, our objective is to reach 50 years.
Yes.
Are we still with the same objective? How is the status? They knew the situation at that moment was like trying to fight with these ships every day, temperature, turning off the heaters, turning back them on, energy, trying to figure out how to make them work. How is, if you compare it with 4 years ago, how are we right now? I mean, besides the Voyager One problem.
Uh, if we solve the Voyager 1 problem, we basically will have two spacecraft that are operating normally. As you said, every year we have 4 watts less power on each spacecraft.
Yeah.
So things are getting colder, less power. And so we have to decide what we turn off every year to keep that power level, at a level that we can keep operating the spacecraft. So that's definitely true. Aging hardware. We're at a point where the hardware is long past its warranty, long past its lifetime. And so we have to worry about that. Cosmic rays can sometimes, these very, very energetic particles that are traveling at very fast speeds can hit components and sometimes cause damage. So, but we're still on our 50-year plan. The goal is to see now if we could get at least one Voyager, hopefully 2, to the 50-year anniversary in 2027. So that still is our goal. We'd like to get them beyond that. It's possible. We found creative ways with the power and with the fuel, et cetera, that perhaps at least 1 or 2 of the instruments could continue to operate, and we could continue to point the antenna at the Earth, sending back data into the 2030s. So we'll just have to see what's in store for us.
Linda, what's the day-to-day communications with, let's assume Voyager 2 that is working properly? It is on an everyday basis. The Voyager 2 is sending, okay, I'm fine, and this is the data I have, this is the scientific data I have, like, every day. How do you communicate with them?
You're right. We get Voyager data back every single day. What happens is Voyager is always sending back science data and engineering data on the health of the spacecraft. And whenever we turn one of our deep space network stations toward Voyager, then we can receive those data and learn more about the interstellar medium and also the health of the spacecraft. So we also have similar passes for Voyager 1. We use those to look at what's coming back from Voyager 1. We got the memory readout that way. And so every day we get, maybe 8-10 hours a day of information back either from one of the Voyagers.
And you, as a project scientist, what is it that you're working right now? What is the most important scientific information that you are working at this moment with the spacecrafts?
Well, the interstellar medium is very interesting. We're out beyond this boundary. We're out beyond this boundary called the heliopause, and that's the boundary between the sun's influence and the solar wind. Basically, you can imagine two winds balancing each other and creating this boundary. Yes, that there it's shown there. So now it's a little bit dated because Voyager II now is also outside. Voyager I crossed the heliopause in 2012, Voyager II in 2018.
Okay.
So they're exploring interstellar space. And what's out there is a lot of material from supernova explosions. The star reaches the end of its lifetime, it explodes, it puts all this material out into space. And that material can then be measured by Voyager. It forms giant bubbles. Those bubbles can touch, overlap, and we can then see what the composition of it is. We can measure the magnetic field. And what's so intriguing, Voyager's there making in situ measurements around the spacecraft. And there were some ideas and theories and models about what we would see. And in many cases, those models aren't quite right. And so Voyager is getting a chance to provide the information that modelers will need to have a more accurate picture of what's happening just outside the heliopause. For instance, we find that the sun's influence continues out past the heliopause. There are these electromagnetic waves called shocks that propagate out. We can see those with Voyager I and Voyager II. Starting in 2020 on Voyager I, we saw something where there was a sudden jump in both the electron plasma density and in the magnetic field. And we call it pressure front 2. And it, rather than sort of decreasing and going away in a few months, instead it's persisted now for over 3.5 years. And up until the moment that Voyager I stopped communicating, we were seeing information about pressure front 2. And so one of the first things we're going to do when we get Voyager I back is to see if pressure front 2 is still there, what it's doing, what else it might be telling us, that that space between the stars where the heliopause ends and out between the stars is not empty. There's a lot of interesting things going on with cosmic rays, with the plasma, the magnetic field. If you could see it, it might look like an ocean with waves jostling and lots of turbulence going on as well, if you could see it with your eyes.
So the two Voyagers are helping you to confirm what scientists believed happened in interstellar space, or the data arriving is like, oh wow, this is completely new, we didn't know anything about this?
Much of the data that are being sent back is indeed telling us that there's something new going on, something unexpected that the models wouldn't predict. We have other spacecraft inside the heliopause, closer to Earth, that are looking outward and making sort of measurements along the line of sight and trying to make maps of what the interstellar medium would look like. And so we can now compare them to data from Voyager, which is looking now from the outside looking in, and compare those data sets and see how we can better understand the interstellar medium.
Linda, is there any information that you are scared to lose because of this Voyager I problem, or is it still in its memory, or it is okay if he start communications again, they can observe, make observations again and send the information back, or you're still waiting to obtain that information?
Well, Voyager sends back data continuously, and so we're not saving that information. We have a tape recorder that still works on Voyager I, but the information since the anomaly started in mid-November, we won't get those data back. Those data are lost. They were sent into space and not recorded on the spacecraft. And so what we're hoping is when we get the spacecraft back, then we'll get new data and that information from that point in time back from Voyager.
Right, because the Voyagers have a kind of very old tape or digital tape recorder that they need to rewind and then record again, send information. That's unbelievable.
It's amazing that digital tape recorder is still working.
It's still working.
Right, and when Voyager I is working, what we would do is record just one frame of data a week, and that's from the plasma wave spectrometer. And it's what we call our wideband data, and we can use the wideband PWS data to actually look at the plasma density in the interstellar medium. So 1 frame a week, and every 6 months we play back every 6 months we play back the track on the tape recorder. So
Wow.
it's just amazing that tape's still going across the heads to record and to play back, and it's still working. So that's amazing.
Linda, when you see this, when you see the team, the Voyager team working, trying to solve every day to keep the ships working and sending data, they're most working on the operative side of the mission, right? Trying to keep the spacecraft alive and working. You, as a scientist, you receive the information from them, and you have another team of scientists working with you. How many of them are?
Each instrument has a team of scientists that look at the data, and in some cases, those team members have been with Voyager since Voyager launched. And there are many new team members that have come in, training the next generation of scientists. And so each instrument team looks at their data, calibrates it, analyzes it, archives it, and then gives presentations. We have twice a year have science steering group meetings, and they give presentations at those meetings. We also bring in the people that are doing the modeling, and they the ones that take the Voyager data, and can they use their models to explain what we're seeing in the data. And it's really not on the Voyager teams, it's not that many team members on the individual teams. It's probably just a few tens of scientists, but then there's a larger group outside of Voyager that are the next generation of scientists, probably twice, maybe 3 times as many, who are looking at the data in some way or another and comparing it to missions that orbit the Earth, other missions that are flying.
Yeah, because I was reading that Voyager started with, like, in 1977, in the 80s, like 1,100 people in total, and now the team is like 11, 12 people.
Right. The flight team is only 11 or 12 people.
Exactly, but the scientists are depending
They're
on
more scientists. Yeah. But some science teams, they might be as small as 2 or 3 people. Other science teams might have 10 or 12 people.
So Voyager 1, we have a hope to recovery. Is any time frame that you think, okay, we're going to send another command or another instruction to see if we are figuring out what Voyager 1 want to tell us? Is there any moment that you think this could be solved?
In looking at what might happen, the thinking is it'll probably take a couple of months at least. And that part of it is because we don't know, once we start to try and fix Voyager, what might happen. And so the estimate is probably on the order of a couple, maybe a few months, to make sure that we have to get this programming fixed, any places where the memory is bad, program around it. And then we have to figure out the best way to restart this computer that hasn't been working with the instruments. And do we have to do any reinitialization of the instruments, anything on the engineering side? So it's just carefully going through all of those steps to sort of bring the system back up and see and get it working again.
With the two Voyagers working, assuming that they're both working and towards the 50 years, what that worries you the most? The lowest temperature, and that maybe the fuel is like freezing and the spacecraft cannot point toward Earth. What is your biggest concern?
Probably the decrease in power. We think we have a plan where we can manage that decrease in power by turning off. We've been turning off a lot of the subsystems on the spacecraft. Yeah. Ultimately, we'll have to start probably in 2027, maybe about the 50th anniversary, look at starting to turn off some of the science instruments one by one to keep enough power to keep the rest of the instruments operating and the spacecraft operating. So it's really the power. And you're right, with the decreasing power, as you turn off more subsystems, that's less heat to keep the thruster, tubes and everything warm. So we worry about maybe the fuel perhaps getting a little too cold, perhaps freezing. So, and then of course the aging hardware. You don't know, we're so far past the expected lifetime of the hardware that there's lots of potential for hardware failures as well. So just trying to balance and do the best we can to juggle all of those.
Linda, crazy question. Tomorrow they call you and they tell you we are launching Voyagers again next year. Voyager 3 and 4, same profile of mission. Would you change any scientific instruments or incorporate any new ones, knowing what they're going to get and trying knowing that they're going to be in an interstellar space? Is there something that you would like to incorporate?
Well, relaunching the Voyagers and knowing that they might go into interstellar space might include more instruments to measure the particles and fields, perhaps make them more sensitive, since the density of plasma and magnetic fields around planets is so much greater than we're measuring in interstellar space. So maybe increase the sensitivity so they can measure even smaller quantities. These instruments were really designed to study planets and the information around planets, not the interstellar medium. There is an idea for a new mission called the Interstellar Probe that would carry a suite of instruments, taking the information we've learned from Voyager and try and go on an even faster trajectory to go out perhaps even further than Voyager. But you're probably looking at a mission that it hasn't started to be built or formulated completely yet. There's some ideas and some papers out there, but it's probably a decade or so away from actually happening. And then it's going to just take time. It took Voyager over 46 years to get to 160 AU. They'd like to go to 500 AU and go fast enough to get there in say 50 years or so.
What is the main motivation right now for the team? I know that, for example, from watching this movie, the motivation is like for an engineer, it's a challenge to go every day and try to make this the Voyagers, keep them working. But for the scientific team, is what's the day-to-day motivations to be working on such a incredible mission?
I think the day-to-day motivation for the scientists, I think for the flight team as well, is just the unique science and the new information that Voyager is returning, and to be part of a mission that's helping us extend our knowledge about the interstellar medium and kind of the role. How does our solar system fit? How did our solar system form? What can we learn that might tell us about how that might have helped life form on Earth, for instance, or how the planets might end up being positioned in our solar system, and also to look beyond our own star and to look at other stars and the planets around those stars. We can actually see the effects of a heliopause around other stars. We call it an astrosphere. If conditions are just right, we can see those, study them, compare them. And so in a sense, it kind of circles back to learning more about ourselves. But first and foremost, just learning what we can about this new place that no one has ever explored before, and to be part of just continuing to go out as far as we can before we run out of the power or something.
I wonder how influential the Voyagers have been in the scientific and engineering community, the same way Apollo was for many generations. I bet that a lot of young scientists are getting into this career because of the Voyagers, right?
That's absolutely true, that many young scientists and young engineers can often point back and say, I was in third grade when Voyager flew by Jupiter, or I wasn't even born yet when the Voyager launched and flew by the planets. And so many stories from people that really see Voyager as something uplifting and something that's helped them think about their careers and what they might want to be doing. And just so many, well wishes and offers to help. Well, I'm willing to help in any way I can. Let me know. Or can we send you cookies to say thank you for all the hard work, that you're doing? Just so much expression of gratitude and interest in these two spacecraft. In fact, I think I got an email from someone who said, my dad worked on Voyager. We have these boxes in our garage. We don't know what's in them, but it's things he saved from his time on Voyager. Do you want us to send them to you? Maybe they have something that can help you figure out what's going on with Voyager. And that's just the kind of, outpouring of support. Or I think a third grade class sent us sort of a get well card to Voyager I. So there's just a lot of interest and things coming out for Voyager.
Well, let me tell you, I was a little boy when Voyager's launched. I still remember that moment, and I'm sure that that ignited the passion that I still have today. And I really appreciate your time, Linda. I know you're busy, and I want to thank you and the rest of the team for trying to extend this mission as much as possible, because it's such a legendary mission and historical. All right, and we hope
Right.
it could last many more years. But we know that we are approaching the end. But I'm crossing fingers to reach the 50-year anniversary. I think they deserve it.
Absolutely. And once the Voyager spacecraft, no longer are communicating with Earth, they still have a mission. And
Yes.
that's we are silent ambassadors. Each carries a
Mm-hmm.
golden record
Right.
with the sights and sounds of Earth. And so maybe, who knows? It's going to take tens of thousands of years or more to fly close to any other star. And maybe someone will find Voyager someday. And on the cover, there's a map of using pulsars of how to find the Earth. And maybe someday somebody will come by and say, hey, we found your spacecraft. We're bringing it back.
That would be amazing. Linda, thank you so much. It was a pleasure talking to you, and I really hope to have to receive good news in the upcoming months. We'll be in touch. I would love to know if we are talking again properly with Voyager 1, and to have two incredible ships outside the solar system. So thank you again.
You're very welcome. It was a pleasure. And I'm very grateful to be part of the Voyager mission.
Thank you. Bye.